Good evening, friends. Today we are discussing Buckingham's pi theorem in dimensional analysis. In earlier class we have seen Rayleigh's method. So Rayleigh's method is restricted to maximum of 4 variables. When the number of variables stated in the given problem is more than 4, it is difficult to solve. Then in that case we are going for Buckingham's pi theorem. Here a numerical is taken to explain in steps how to solve the problem using Buckingham's pi theorem. So that the problem states like this: the resisting force R of a supersonic plane during its flight is depending upon the length of the aircraft, so that is L, velocity V, and the viscosity of the air, so that is mu, air density, so that is rho, and bulk modulus of the air, that is K. It is asked to express the functional relationship between these variables and the resisting force of the supersonic plane. Now step 1. So we need to show which is the dependent variable and which are independent variables. So in this problem, the resisting force of the plane, capital R, so is the dependent variable. So it is depending on the other variables like length of the aircraft L, velocity V, and air viscosity, so that is mu, and it is depending on air density, so that is rho, and the bulk modulus of air, so that is K. So we say that R is the function of L, comma V, comma mu, comma rho, comma K. So this relation will be rewritten as f of this R, comma L, comma V, comma mu, comma rho, comma K is equal to 0. Now the total number of variables here in the given problem is 6. N is equal to 6, out of which 1 is the dependent variable, that is R. The remaining 5 are independent variables. Totally number of variables used in the problem is 6. Now the number of fundamental dimensions we have m is equal to 3. Which are the fundamental dimensions? Length, mass, and time. So the other quantities will be called as derived quantities. The derived quantities are derived from these fundamental quantities, that is L, M, and T, that is length, mass, and time. So number of dimensionless pi terms. So in Buckingham's theorem we are using these pi terms. So the number of these pi terms used in the problem will depend on this n minus m. So in this particular case, number of variables used is 6 and number of fundamental quantities by default, so that is 3. So 6 minus 3 is equal to 3. That means we are using the number of pi terms as pi 1, pi 2 and pi 3. If this n minus m becomes 4, so then we'll have one more pi term, so that is pi 4. If it becomes 5, so we'll have pi 1, pi 2, pi 3, pi 4, pi 5, so on. Now function of pi 1, comma pi 2, comma pi 3 is equal to 0. Now the next step 2. So each pi term contains m plus 1 variables. Here m is equal to 3. So we will have m plus 1 variables. That means each pi term will be having totally m plus 1, that is 3 plus 1 variables. So that is 4 variables where m is equal to 3 and also the repeating variables. Out of the 6 variables that is given here, the 3 variables will be selected as the repeating variables, and since R is dependent variable, that is resisting force of the plane is dependent variable. It cannot be considered as the repeating variables. Out of the remaining 5 variables, that is L, V, mu, rho and K, one should represent the geometric property, second variable should represent the flow property, and the third variable should represent the fluid property. So you are having 5 variables. Out of these 5, so one should represent the geometric property, the other variable should show the flow property, and the third variable should represent the fluid property. Now if I consider L, V, mu, rho and K, okay, which is the variable represent the geometric property? Geometric property will be like length, volume, area. So these are coming under geometric property. So L is now selected as the repeating variable, which is representing my geometric property. Then other variable must represent the flow property. Okay, now V, velocity. Velocity is depending on the type of flow. So velocity is representing my flow property, flow property, and the third one must have fluid property. So out of these 5 variables, I have my density and viscosity and even bulk modulus. All these 3 are representing my fluid property only. So I can select randomly any one of these 3. So I am taking mu. So that is viscosity as the fluid property. Instead of mu, we can take density as well as bulk modulus also, which are also representing the fluid property. So randomly I am taking viscosity as the fluid property. Now let us see how to write individual pi term. So as it is said that individual pi term contains 3 variables which are repeating. So we have selected length, velocity and density, right? As I said earlier, so you can take density, viscosity and bulk modulus. So any one among these 3 can be taken as the fluid property. So either you can take mu or rho or K. So here we are writing density. So that is rho. So L, V and rho are the 3 repeating variables. They have repeated in all the pi terms. So we have totally 6 variables. Out of 6 variables, 3 of them are repeating variables. Which are they? L, V and rho. The other 3 variables I am writing only once. So here we are writing R. So mu and K. So each pi term will contain, so totally m plus 1 variables. So that is 3 plus 1, that is 4 variables. Out of 4, 3 of them are repeating variables. So L, V and rho are the repeating variables. So the other variable we have written here. Once again in the pi 2 term, L, V and rho are the repeating variables. We are writing one more variable. So in pi 3, once again we have 3 repeating variables and one more variable here. Then coming to step 4, each pi term is solved by principle of dimensional homogeneity. So pi 1 is having no fundamental dimensions. So that's why it is m to the power of 0, L to the power of 0 and t to the power of 0. So we have pi 1 term. So L to the power of a1. So L, so length of the aircraft. So I am writing L to the power of a1. And then velocity. So that is nothing but distance by time taken. So distance is L, time taken is t. So L by t. So it is nothing but L t to the power of minus 1 to the power of B1. Then this density is mass by volume. So mass is in m, volume is L cube. So mass by volume means m divided by L cube, that is written as m L to the power of minus 3 to the power of C1. Then R, resisting force. So force is nothing but having the basic quantity as m L t to the power of minus 2. So F is equal to ma. So R is also force, that is resisting force. So whatever units I have for the force, for R also I have the same units. So force will be written as m into A. So mass is given in m and acceleration is given as meter per second square. So that's why it is L divided by t square. So in the sense L t to the power of minus 2. So this is having the quantity mass into acceleration. So R will be written as the force. So which in turn force is nothing but the product of mass into acceleration. So mass is written as m, acceleration meter per second square. So meter means length and second square, that is t square. So L by t square. So I am writing it as L t to the power of minus 2. It is having no power here. So now equating the powers of L, m and t on both sides. For length, so what is the power of length L on the left hand side? It is 0. So on the right hand side I have L to the power of A1, L to the power of B1 and L to the power of minus 3C1 and L to the power of 1. So all together it is A1 plus B1 minus 3C1 plus 1. Similarly, the powers of m. So on the left hand side it is 0. So the power of m on the right hand side, m to the power of C1 into m to the power of 1. So it is C1 plus 1. Similarly, the power of t on left hand side it is 0. On the right hand side it is t to the power of minus 1b1 minus 2. So it is minus b1 minus 2. So solving these three equations, I am getting a1 as minus 2, b1 as minus 2 and c1 as minus 1. Substituting these a1, b1, c1 in pi 1 term. So we have, so that is L to the power of a1. What is a1 here? So that is minus 2. Then v to the power of b1. What is b1? It is minus 2. So v to the power of minus 2. Then rho to the power of c1. So rho to the power of c1. c1 is equal to minus 1 and into r. So that we are writing here. So now pi 1 I am getting it as r divided by L square v square rho. So that is what my pi 1 term here. Okay. Similarly, if you go to pi 2 terms, so I don't have any fundamental quantities on the left hand side. So m to the power of 0, L to the power of 0, t to the power of 0 is equal to, okay, here L to the power of A2. L I am writing as it is A2 and V velocity. So it is the same as the term pi 1 here. So that is L t to the power of minus 1 to the power of B2. Similarly, my density will be written as m L to the power of minus 3 to the power of C2. And viscosity is having the fundamental quantities m L to the power of minus 1 t to the power of minus 1. In the earlier class, the fundamental quantities and the derived quantities we have given the example. You can refer them. Now equating the powers of L, M and T on both the sides for length L. So the power is 0 on the left hand side. On the right hand side it is L to the power of A2 and L to the power of B2 and L to the power of minus 3C2 and L to the power of minus 1. Considering all this, we have A2 plus B2 minus 3C2 minus 1 is equal to 0. Similarly, the power of M on the left hand side is 0. On the right hand side, we have M to the power of C2 and M to the power of 1. So it is C2 plus 1. And then for the time t, the left hand side the power is 0. On the right hand side we have t to the power of minus 1 b2 and t to the power of minus 1. So finally we have minus b2 minus 1. Solving them, we are getting a2 b2 c2. Substituting a2 b2 c2 in your pi 2 term, we are getting pi 2 as this. Then similarly for the pi 3 term, so that is L to the power of A3, V to the power of B3, rho to the power of C3 into K. So now taking the powers of Lm and T on left side and Lm and T on right hand side and equating the powers on both the sides, we are getting A3 is 0, B3 is minus 2, C3 is equal to minus 1. Now substituting this A3, B3 and C3 in our pi 3 equation. So we have pi 3 is this. Now we'll come back to this f is equal f, the function of pi 1 comma pi 2 comma pi 3 is equal to 0. So f of, we are writing pi 1, so that is this, and pi 2, so that is this, and pi 3, so that is this, is equal to 0. So we are taking r on the left side of the equation because r is the function of the other three variables. So and rearranging the terms, we are getting our equation like this. So this final relation shows that the resisting force of the supersonic plane is function of these variables, that is density of the air, length of the aircraft, velocity of the aircraft and viscosity as well as the bulk modulus. Thank you.